Hello students, let's do inequalities, exercise 15. We're on page number 181 and we are doing question 5. So before that, let me just go through once again what an inequality is, because you're doing it for the first time, isn't it? In class 7, it's a new chapter that has been introduced. So what is an inequality? It's a statement, it's a mathematical statement which shows that two expressions, that is the left hand side and the right hand side, are not equal. That forms an inequality. Now, if you have an inequality with one variable, you know what a variable is, isn't it? Having at least one variable, that is called an inequation. Now, let me give you an example. Now, if I say 3x plus 5 is equal to 12, this equal to sign tells us that this is an equation. So what is an inequation? It will not have an equal to sign. Instead, it will have other signs and symbols like, I can say 3x plus 5 is greater than 12. So this symbol, greater than, is what is used in an inequation. Or we can say 3x plus 5 is greater than, and if you have a line drawn, then we say greater than or equal to. So the sign underneath, the line that is drawn underneath the greater than sign tells us it's equal. Okay, so how do we read this? We read this as 3x plus 5 is greater than or equal to 12. Then what are the other symbols we use? 3x plus 5 is less than 12. So we use that symbol to show it is less than, or we have another symbol also. We say it's less than or equal to. So this is again less than or equal to. So what are all the symbols that we use in an inequation? We say greater than or equal to, less than or equal to. So these are the symbols that we use in an inequation, and we don't use the equal to sign. So let's begin this first sum. So 3x minus 2, let me write down the question, by 4 is less than or equal to 4. And x belongs to, this symbol is belongs to, and w is whole numbers. So x belongs to whole numbers. So let's write down a few values of whole numbers starting from 0. Whole numbers begin from 0. 0, 1, 2, 3, 4, 5 and so on. Now let's solve for x here. 3x minus 2 is less than and equal to 4 into 4, because we have transposed this 4, which is division here, to the right hand side. So it became multiplication. 3x minus 2 is less than or equal to 4 fours are 16. So 3x will be less than or equal to 16 plus 2, because we have transposed the minus 2 to the right hand side. It's become plus 2. So 3x is less than or equal to 18. That means x is less than or equal to 18 divided by 3, because here 3 is multiplication. When we transposed it, it became division. Now we can cancel this 3. 6's are 18. So x is less than or equal to 6. So now let's look at the whole numbers there. So all the numbers that are less than 6 will be 5. 5, 4, 3, 2, 1 and 0. But it also says equal to 6. Isn't it? How do we read this? X is less than or equal to 6. So less than, we have all the numbers up to 5. Since it says equal to 6, we have to include 6 also. So let's write our solution set. X is equal to 0, 1, 2, 3, 4, 5 and 6. So these are the values of x, and this is the solution set for question 5. Question 6. 3x plus 2 by 5 plus 5 is less than 0, and x belongs to n, which stands for natural numbers. So let's write down a few natural numbers here just for our information. Natural numbers are counting numbers that begin from 1. 1, 2, 3, 4 and so on. Okay, so now let's solve for x. 3x plus 2 by 5 plus 5 is less than 0. So 3x plus 2 by 5 will be less than 0 minus 5 because we have transposed this plus 5 to the right hand side. It's become minus 5. So 3x plus 2 by 5 is less than 0 minus 5 is minus 5. 3x plus 2 is less than minus 5 into 5 because again here we have transposed 5. 5 is division. When we took it to the right hand side, it's become multiplication. So 3x plus 2 is less than 5 5s are 25 and minus 25. So 3x will be less than minus 25 minus 2 by transposing plus 2 to the right hand side. Now 3x is less than minus 25 minus 2. Signs are the same. Put the same sign and add. 25 plus 2 is 27. So 3x is less than minus 27. X is less than minus 27 by 3. So 3 has a plus sign. So here it will be minus. Minus into plus is minus. Now 3 9s are 27. So minus 9. So according to this, x is less than minus 9. Okay, so all the numbers less than minus 9 we have to write. So what are all the numbers less than minus 9? Remember the number line, integers number line. As you move to the left, the value keeps decreasing. So all the numbers less than minus 9 will be the numbers to the left. So that will be minus 10, minus 11, minus 12 and so on. All these numbers. So we have to write minus 10, minus 11, minus 12. But look at the question given. Given to us is x belongs to natural numbers. And natural numbers are all numbers starting from 1. We don't have any negative number here, isn't it? That means x does not have a value. That means there is no solution to this. There is no solution set for this question. So x is less than minus 9 and x belongs to natural numbers gives us an answer which says there is no solution. There is no solution set for this. Okay, so x has no value here. Going on to the next question. Question 7. Solve 5 minus 2x is greater than or equal to x minus 12. This time x belongs to whole numbers. So let's write down a few whole numbers. Whole numbers are numbers that start from 0. So 0, 1, 2, 3, 4, 5 and so on. Now let's solve for x here. 5 minus 2x is greater than or equal to x minus 12. So as you can see, we have x terms on the left hand side as well as the right hand side. So let's get all the x terms to the left hand side and all the numbers to the right hand side by transposing. So we already have minus 2x here on the left hand side. Now we are going to transpose the x from the right hand side. We have an x here. We're going to take it to the left. So here it is plus. When it comes to the left, it becomes minus. So that is minus x is greater than or equal to. Now on the right hand side, we have minus 12. We're going to transpose this 5 to the right hand side. So that becomes minus 5. So let's simplify this. Minus 2x minus 1x. Signs are the same. Put the same sign and add. 2 plus 1 is 3. So that is 3x minus 3x is greater than or equal to. On the right hand side, signs are the same. Put the same sign and add. 12 plus 5 is 17. So here, now we're going to say x is greater than or equal to minus 17 by minus 3. Now be very careful. Watch this carefully, children. Now we have learned properties of inequations. So we said if you add a number on the left hand side and add the same number on the right hand side, the inequation does not change. Similarly with subtraction. Now with multiplication and division, if you multiply with a positive number on the left hand side and multiply with a negative number, with a positive number on the right hand side, then the inequation does not change. Whether you multiply or divide by a positive number, inequation will not change. But when you multiply or divide by a negative number, here we are dividing by a negative number minus 3. The inequation will get reversed. The greater than sign will now change to lesser than sign. So we need to change that. So let's change it to a lesser than sign. So now let's read the question again. X is lesser than or equal to minus 17 by minus 3. Now let's simplify this, minus 17 by minus 3. So minus 17 by minus 3, minus into minus is plus, so 17 by 3. Let's divide 17 by 3. So this is 3, 5s are 15, minus 2. So we've got this as 5, 2 by 3, a fraction. Now if I have to make this a decimal number, let's work it out and get a decimal number also. So we can try both ways. 3, 5s are 15, minus 7 minus 5 is 2. So if I have to make it a decimal number, I need to continue my division. For that I must put a point here and add a 0, and that 0 I can bring down. Now to continue, I need to carry this point up. So now I have 20, 3 6s are 18, minus, again 20 is here, so 10 minus 8 is 2. I can put one more 0 and I can continue. Now again I've got 20, so 3 6s are 18. So as you can see, this will go on and on, isn't it? So we can stop with this 5.66. So this is 5 2 by 3 or 5.66. So now we have to get our solution set. X is less than or equal to one of these numbers, 5 2 by 3 or 5.66. So let's take 5.66. Now 5.66 is a number greater than 5. Okay, this is greater than 5, but it has not reached 6 as yet, but it is greater than 5. So if we have to write a solution set for this, we'll have to write all numbers according to this. Less than 5 means we need to write all the numbers from 4 backwards. So 0 to 4 we should write, but it also says equal to also. So we need to include 5. So these are the numbers we'll write from 0 to 5. So 0, 1, 2, 3, 4, 5. Okay, so these are all the whole numbers that X can take the value as. So this is the solution set for this question. Question 8. Solve. 2 into x plus 2 plus 9 is greater than 3 into x minus 1. And x belongs to natural numbers. So let's write down a few natural numbers. Natural numbers are counting numbers starting from 1. 1, 2, 3, all these numbers. Okay, so now let's work this out. Now, since you have 2 before the bracket and there is no sign, doesn't say minus or plus, isn't it? So if there is no sign, it's understood that it is multiplication. So let's multiply 2 into x. 2 into x is 2x, and then we multiply 2 into plus 2. So 2 2s are 4. Then we write the next one, which is 9. Now this is greater than, here also we have to multiply. 3 into x is 3x, and then we multiply 3 into minus 1, which is 3 1s are 3, minus 3. Now here on the left hand side we can simplify this, 4 plus 9. So we get 2x plus 4 plus 9 is 13 is greater than 3x minus 3. Again, as you can see, we have the x terms on both sides. So let's get the x terms to the left side and the numbers to the right side. So we have 2x already here. we are transposing 3x to the left hand side. It becomes minus 3x, and this is greater than, on the right hand side we already have minus 3. We're now going to transpose plus 13 to the right hand side. It becomes minus 13. So simplify the left hand side. Plus and minus signs are different. So put the sign of the bigger number and subtract. 3 minus 2 is 1. 1x is greater than, on the right hand side we have two minus signs. Since signs are the same, put the same sign and add. 13 plus 3 is 16. So now we're going to solve for x, isn't it? So let's write only x here, and x is greater than. On the right hand side we have minus 16, and I'm transposing this minus 1, which is multiplication. Here it is multiplication. So when it goes to the right hand side, it's going to become division. And as you can see, now the division is by a negative number, isn't it? So if the division is by a negative number, then we have to reverse the sign. So greater than will now become less than. So let's remove the sign and reverse it and write less than. So x is less than, now let's work out, minus 16 by minus 1. Minus into minus is plus, 16 divided by 1 is 16. So x is less than 16. So now we can get our solution set for x. We can get all the values of x. All the values of x are natural numbers which are less than 16. So we have to write numbers starting from 1 up to 15. So let's write that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15, because it says x is less than 16. So these are all the values of x. This is the solution set for question 8. Question 9, solve. 5 is less than or equal to 3 into x minus 2 plus 4. And x belongs to whole numbers. W stands for whole numbers. Now we need to draw a suitable number line to represent the solution obtained. So first let's write down the values for a whole number. Whole numbers start from 0. So let's write a few numbers. 0, 1, 2, 3, 4 and so on. So now let's solve for x. So 5 is less than or equal to, now here 3 we have to multiply it by x. So 3 into x is 3x and multiply 3 into minus 2. So the sign is minus, 3 2s are 6. Now let's write the 4 there, plus 4. So 5 is less than and equal to 3x. Now we can simplify the whole numbers minus 6 and plus 2. Signs are different, so put the sign of the bigger number and subtract. 6 minus 4 is 2. Now let's get all the whole numbers, all the numbers to the left hand side. Okay, so we already have 5 here, and let's transpose minus 2, it becomes plus 2. And this is less than and equal to 3x. So this is 7. 7 is less than and equal to 3x. We can also say 3x is greater than. Okay, if you read from this side, we say 3x is greater than or equal to 7. So now we're going to solve for x. So here we write x. On this side we have only x. We're transposing 3 to the other side, so it becomes 7 by 3. So 7 by 3 is less than or equal to x, or x is greater than or equal to 7 by 3. Now let's divide 7 by 3 and see what we get. 3 2s are 6 minus, we have 1. Now my answer here is 2, 1 by 3. If I write it as a fraction or a mixed number, this is what I get. Now let me get a decimal number. So let me divide 7 by 3 to get a decimal number. 3 2s are 6 minus 1. To get a decimal number, I need to put a point here and a 0. I can bring that 0 down. Now my number is 10. Then I need to carry that point up. 3 3s are 9 minus 1, I can still continue. I can put a 0. As you can see, again I've got 10. So 3 3s are 9. So this will go on. This division will go on. So I can stop with this. So I've got a mixed fraction and I've got a decimal number also. So that means x is greater than or equal to 2/1/3 or 2.33. So let's look at our whole numbers. Let's look at all the numbers greater than 2.33. Now 2 is here. Now 2.33 will be in between 2 and 3. So it will be here. So 2.33 is here. Okay. So we have to write all numbers that are greater than 2.33. That means starting from 3. And it also says equal to 2.33. Now 2.33 is not a whole number, isn't it? So we have to leave out 2.33 and write all numbers from 3 onwards. So what is the solution set for x? The solution set for x will be, put the curly brackets to show that it is a set. It will be all numbers from 3. 3, 4, 5 and so on. Now we need to draw a number line to show this. So we have a number line here. So let's have a few numbers 3, 4, 5, 6, 7, 8. Okay, so here we have 2, 1, 0, -1, -2, -3, -4, -5. Our whole numbers begin from 0. From 0 onwards, we have all whole numbers. Okay, because they're all positive numbers and starting from 0. And 2.33 is in between here and it's not a whole number. So we start from 3. So let's mark 3 now. So on the number line, we're going to mark the solution set, all the values of x. 3, 4, 5, then we have 6, 7, all numbers, 8. Now there are more numbers, isn't it? It goes on and on the right hand side. Now to show that, we have to highlight the arrowhead on the right side. On the right side we have an arrow, isn't it? Let's highlight that arrow. Now this is to show that our numbers are going on the right hand side. So we have now represented our solution set on the number line. We've got all numbers from 3 onwards highlighted, and we've also highlighted the arrowhead, okay, to show that the numbers are going on. Question 10. -10 is less than -5 plus 2x, and x belongs to set of integers. So let's write down a few values for integers. So integers will have negative numbers. So let's put a few negative numbers, -3, -2, -1, and it'll have 0, and it'll have positive numbers. Okay, so we'll just do this. Here also there are dots to show it goes on the side also. Okay, now let's solve for x here. So we have -10 is less than -5 plus 2x. So let's take all the numbers to the left hand side. So we have -10 and I've transposed -5, so it becomes +5 is less than 2x. So here signs are different, so put the sign of the bigger number and subtract. 10 minus 5 is 5. This is less than 2x. Okay, or 2x is greater than -5. We can also read it that way. So here what will I do? I'm going to transpose 2, which is on the right hand side, and this is multiplication. I'm going to transpose it to the left hand side. So it becomes -5 by 2 is less than x, or x is greater than -5 by 2. Now let's divide -5 by 2. We'll divide 5 by 2 and see what we get. 2 2s are 4 minus 1. Okay, so here we get 2 1 by 2. This is the fraction form. Now let me try and get a decimal also. So 5 divided by 2. 2 2s are 4 minus 1. So I can continue to get a decimal. So this is a point and I put a 0. I can bring that 0 down. It's 10. Now I carry on. I put a point there. 2 5s are 10. So here this decimal division is over. So I've got 2.5. Okay. So now I can write -2.5 is less than x, or x is greater than minus 2.5. Okay, so we need to get all numbers that are greater than minus 2.5. So let's draw our number line. So we have our number line here, and let's put down our numbers. So if I put my numbers here, let me put 0 here. So I have minus 1, minus 2, minus 3, minus 4, minus 5. And here I have 1 to all the positive numbers, 3, 4, 5, 6, 7, 8. Okay. Now I need to get numbers that are all greater than minus 2.5. Now remember, as you move to the right, the numbers keep getting bigger and bigger. If you move to the left, it gets smaller. So we are going to look at all numbers which are moving to the right greater than minus 2.5. Okay, now 2.5, where do you think it will be? Now 2.5 or 2.5. 2.5 is between 2 and 3, isn't it? 2.5 will be between 2 and 3. So minus 2.5 will also be between minus 2 and minus 3. So it will be here somewhere. So this is where you get minus 2.5. And here we say x is greater than minus 2.5. That means it's greater than this particular point here. So I include all the numbers that come after minus 2.5, including minus 2. So minus 2, minus 1, 0, all these numbers which are to the right of minus 2.5 are greater than minus 2.5. So that is my solution set. So first let me write my solution set here. So that will be 2, that's minus 2, minus 1, 0. Then I write 1, 2, 3, 4, all these. It will go on and on. So this is my solution set. And remember how I got minus 2 also? Because as you can see, minus 2.5 is between minus 2 and minus 3. And here we know that x is greater than minus 2.5. And all the numbers which are to the right of minus 2.5 will be my solution set. So that's how I got minus 2, minus 1 and all the other numbers. Now let's show this on the number line. So all numbers greater will be from minus 2. So minus 2, minus 1, 0. Then we have 1, 2, all these numbers to the right of minus 2.5. All the numbers. Since we have all these numbers on the number line, let's highlight it. So I've got up to 8. Depending on how much you have, you can highlight it right up to the end. Now, we have to highlight this arrowhead on the right side just to show that we are continuing. This continues. The number line continues here. So we are highlighting this portion. So this is how we show our solution set on the number line. Remember how important it is to find where 2.5 is. It's in between minus 2 and minus 3. And anything greater than that is our solution set. So that's how we got all these answers here. Okay, all these points that we have marked. So children, with this we come to the end of this chapter. Thank you children.